Hi all, I am K. Surya, working as assistant professor in the Department of ECE at SNS College of Technology. In this video, we will see about Playfair Cipher. Playfair Cipher was proposed by Charles Winston in 1889, but it was named for one of his friends, Lord Leon Playfair, because he popularized its uses. It is the most popular symmetric encryption technique that falls under the substitution cipher. It's an encoding procedure that enciphers more than one letter at a time. In Playfair cipher, unlike traditional ciphers, we encrypt two alphabets, which is known as digraphs, instead of a single alphabet. Let's see the encryption technique. The first step is that you'll be splitting the plain text into digraphs, which means that we will be splitting the plain text into two letters. Then, if the plain text has odd number of letters, we can append a character like Z or X at the end of the plain text so that it will become even. So, for example, you consider the word mango. So, when you split it into two, you will be getting MA, NG, and O will be a separate letter. So, in order to make it as a digraph, we can add a letter Z or X along with it. So, here we'll be adding a letter Z. So, it becomes MANGOZ. After that, break the plain text into digraphs. If any letter appears twice, like in balloon, BALLOON. So LL is occurring twice, OO is occurring twice. So like that, then we'll be using only one letter and you'll be adding a letter X or Z in between. So for example, here you consider the letter communicate. So here M is occurring two times. So when you split it into digraph, you will be splitting it as CO, MX, MU, NI, CA and TE. So in order to perform the encryption, first we have to build a 5x5 matrix for the keyword which is given. Then in the 5x5 matrix, you will be filling the first row from left to right with the letters of the given keyword. If the keywords have duplicate letters, you will be using it only once. It means a letter will be considered only once. After that, you'll be filling the remaining letters in the alphabetical order. Here is shown an example for a keyword monarchy. So you're first filling MONARCHY. After that, the remaining letters of the alphabetical order is filled here. Since A is already present, you're writing B. C is already present, you're writing D. E, F, G, H is already present. So you're writing I bar J. Then K, L, M, N, O is already present. So P, Q, R is already present. So S, T, U, V, W, X, and Z. So here, since you have 26 alphabetical letters, and since it's a 5x5 matrix, you have only 25 spaces here. You'll be writing I and J in the same box. So now consider an example here. Consider the example instrument as the plain text. So after splitting it, you'll be getting IN, ST, RU, ME, NT, and SZ. If both the letters are in the same column, then you take the letter below each one, going back to the top if it is at the bottom. For example, you consider the digraph ME. So in the 5x5 matrix, M and E is present in the same column as shown in the diagram. So you'll be moving downwards. So the ciphertext for M is C and the ciphertext for E is L. The next rule is if both the letters are present in the same row, then you take the letter to the right of each one, going back to the leftmost if it is at the rightmost position. So here you consider the example ST. So since ST is in the same row, the ciphertext for S is T. Since the right letter of S here in the diagram is T, for S you'll be encrypting it using the letter T, and T is the rightmost letter, so you'll be coming back to the leftmost letter, which is the L as shown here in red color. So your S is replaced with T and T is replaced with L. The next rule is if it is not in the same row or same column, then it forms a triangle with the two letters and you take the letter on the horizontal opposite corner of the rectangle. So you consider NT here. So N and T are present in different rows and columns. So this N and T, it will form a rectangle as shown here. Uh, so what will happen is, so the opposite corner of N is R. So N is replaced with R and the opposite corner of T is Q as shown here and T is replaced with Q. So this is the example. So this is a complete encrypted diagram for the plain text instruments. So instruments will be splitting it into diagrams. So I and N is present in different rows and columns. So you'll be getting A and G. And for ST, it is as already told, it is TL. For RU, it is MZ. For ME, it is CL. For NT, it is RQ. And for SZ, it is TX. So the final encrypted message is GA, TL, MEZ, CL, RQ, TX. So this is how a Playfair cipher is working. So the advantages are it is diverse ciphertext. If we scrutinize the algorithm, we can notice at every stage we are getting diverse ciphertext. Thus, more trouble to cryptanalyst. Brute force attacks does not affect it. Cryptanalyze is not possible here, and it's easy to perform the substitution. Next, you'll see the disadvantages. Here, only 25 alphabets are supported. So numeric characters are not supported here. Only uppercase, lower cases are supported. Use of special characters like blank space, punctuations is also not supported here, and it is not supporting other languages except English. So encryption of media files is also not supported here. So hope you understood how to perform encryption using Playfair Cipher. So let us take up some assessment questions. Playfair cipher is an example of answer is polyalphabetic cipher. What is the rule for encryption in Playfair cipher if the letters in a pair are identical? Yes, as you know, a null is added in between the letters. Thank you for watching this video.